Imagine sitting at your desk, watching an attack simulation unfold on your screen. One compromised laptop scans the entire internal network, touches file shares, pings domain controllers, and pokes at application servers it has no business reaching. If your environment still behaves like one big flat network, that scenario is not far from reality. I am glad you are here, because this narration is part of my Tuesday Insights feature in Bare Metal Cyber Magazine, and we are going to unpack what it really means to use network microsegmentation to change that story. Network microsegmentation is a way of designing and enforcing boundaries inside your environment so that only the right systems can talk to each other in the right ways. Instead of assuming everything internal is trusted, you treat the network like a set of small, purpose-built neighborhoods with limited streets between them. Those streets are the allowed flows, for example, a web server talking to an application server, or a backup agent reaching a file share. The focus is on narrowing those flows to what is genuinely needed for the job, not on trusting the entire internal space. You can think of microsegmentation as living in the middle of your stack, between raw infrastructure and business applications. It shows up around application tiers in data centers, between services and security groups in cloud environments, and around sensitive systems like industrial controllers or finance servers in on-premises networks. It is driven by technology because you need enforcement points in the traffic path, but it is also a process because teams have to decide which flows are allowed and keep those decisions current as the environment changes. It works alongside identity, endpoint security, and logging instead of replacing any of them. A lot of people confuse microsegmentation with simply carving the network into more VLANs or subnets. VLANs help with broadcast domains and basic separation, but they often still allow broad any-to-any communication within and between those logical groups. If everything on a VLAN can still talk to everything else, the risk picture has not really changed. Microsegmentation is different because it focuses on the actual communication rules between specific applications, services, and tiers. It is not a magic product you can install or a rebranded firewall. It is a design pattern that forces you to be precise about who talks to whom. Putting network microsegmentation into practice usually starts with something unglamorous: understanding your current traffic patterns. Teams need to know which systems talk to which, on which ports, and for what purpose. That often means looking at flow logs, talking to application owners, and sketching simple diagrams that explain an application in plain language rather than vendor jargon. The goal is to move from anything on this subnet can talk to anything else to this web tier talks only to these application servers on specific ports and nothing else. That change in mindset is the real engine behind microsegmentation. Under the hood, microsegmentation depends on a few key building blocks. You need enforcement points that can see and control traffic, such as traditional or next-generation firewalls, software-defined networking components, host-based agents, or cloud-native controls like security groups. You need a way to group workloads by role, application, or sensitivity, so you are not managing rules one IP at a time. You also need a policy model that humans can read and understand, plus logs that show what is being allowed and what is being blocked. When these parts work together, your environment begins behaving like many small neighborhoods instead of a single open parking lot. A simple example helps make this more concrete. Picture an internal HR application with a web front end, an application server, and a database. With network microsegmentation, you would design things so that only the web servers may receive user traffic from the corporate network, only the application servers may receive traffic from the web tier on a defined set of ports, and only the database may receive calls from the application tier. Administrative access might be restricted to a dedicated management segment. Enforcement points apply these restrictions, and logs show any attempt to bypass them. This whole setup depends on some big assumptions: that you know where those HR components live, that tags or names are accurate, and that someone is responsible for updating the policies as the application changes over time. Once you have basic capabilities in place, common patterns emerge. One frequent use is ring-fencing high-value systems, such as domain controllers, payment processors, or critical file servers. Instead of letting the entire internal network reach these systems, you define a small set of allowed sources and ports. Another pattern is separating environments so that development, test, and production do not freely talk to one another, even if they share hardware or cloud accounts. Many organizations also use microsegmentation to control how partner networks and third-party services reach internal applications, tightening the boundaries around those external connections. If you are working with limited time or resources, it is often smarter to start with a narrow, high-impact scope rather than trying to segment everything at once. One realistic quick win is isolating management interfaces and admin tools. You can group hypervisor consoles, network device management, backup servers, and similar systems into a tight segment, then allow access only from a handful of jump hosts or privileged workstations. That alone reduces the blast radius if a regular user device is compromised. Another approachable step is limiting lateral movement between user subnets so that a single infected laptop cannot scan or attack every other workstation on the network. Over time, more strategic uses of network microsegmentation show up in larger modernization efforts. As organizations move more workloads to cloud platforms or adopt microservices, they use segmentation to define how services communicate across accounts, regions, and clusters. Policies shift away from IP ranges and toward roles or tags that describe what a workload does. Microsegmentation then becomes part of larger stories like zero trust design, ransomware containment, and regulatory compliance for critical systems. The pattern is the same, but the scale is bigger and the tooling more automated. When it works well, network microsegmentation delivers very specific benefits. It makes lateral movement much harder for attackers because every move has to pass through a defined path where it can be logged or blocked. It gives security teams clearer visibility into intended communication patterns, which makes unusual activity stand out more quickly. It also encourages better architecture because describing applications in concrete dependency terms exposes hidden assumptions and unnecessary connections. Over time, that clarity can reduce surprises during incidents and maintenance. The trade-offs are real, though. Designing meaningful segments and policies demands time from people who understand both the network and the applications that run on it. Enforcement points must be purchased, deployed, and maintained, whether they are physical devices, virtual appliances, or host agents. Policy models need to scale, which means grouping workloads by function instead of by individual address. That usually requires closer collaboration between network, security, and application teams, as well as some investment in tools that can visualize flows and manage policy changes safely. There are also hard limits on what microsegmentation can do for you. It cannot fix weak identity practices, unpatched systems, or poor endpoint security. Phishing campaigns and account takeover attempts still need to be handled through other controls. In very complex environments, an overly granular segmentation design can create so many rules and patterns that humans struggle to reason about them, especially if every team invents its own style. Marketing promises of set and forget controls often collide with the reality that environments constantly change, and segmentation has to change with them. You can spot failure modes in how an organization approaches microsegmentation. One red flag is policy by panic, where teams rush to install restrictive rules right after an incident with little understanding of normal traffic. The result is a cycle of outages, emergency exceptions, and angry stakeholders. Another failure pattern is firewall sprawl, where every new application adds another pile of bespoke rules with no shared structure or cleanup. Over time, the rule base becomes so tangled that nobody wants to touch it, and changes move slowly, if at all. Shallow adoption is subtler, but just as dangerous. This happens when a company deploys segmentation technology, but never goes beyond a handful of coarse zones that still allow broad access. Dashboards look impressive, and project documents declare success, yet user networks can still freely scan each other, and critical servers remain exposed to most internal systems. Ownership problems compound the issue. If no one is clearly responsible for keeping application maps and segmentation policies aligned with reality, those policies drift. Applications move, merge, or retire, while rule sets stay frozen in an outdated picture of the environment. Healthy implementations look very different. Teams can describe a small, consistent set of segmentation patterns they use for most applications, such as 3-tier patterns for internal services or standard rings around shared platforms. New projects reuse those patterns instead of inventing brand new structures each time. When an application is deployed or changed, updating segmentation policy is a normal step in the process, not a special project. Security teams can point to specific incidents or tests where segmentation limited damage and to trends that show fewer overly permissive rules over time. Perhaps most importantly, people across network, security, and application teams can explain how segmentation supports their work instead of blocking them. At its heart, network microsegmentation is about seeing your environment as many small, purpose-built neighborhoods instead of one sprawling, trusted city. By defining communication in concrete, application-aware terms, you shrink the space in which attackers can move and make normal operations easier to understand. It will not replace identity controls, patching, or strong endpoint defenses, but it makes all of them more effective by limiting how far a compromise can spread. For most organizations, the useful question is not whether they have perfect microsegmentation, but where tighter boundaries would genuinely reduce risk and confusion. That might mean ring-fencing a few high-value systems, cleaning up how environments are separated, or locking down management access that is too available today. As you look at your own environment through this lens, consider where a handful of well-chosen segments could turn a single flat network into something more resilient, observable, and forgiving when things go wrong.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.